There is a hidden forest that once stretched from Baja, Mexico to Alaska. It supported thousands of species, including humans, by providing habitat and food. But in 2013, something happened to change it, and the kelp forests of Northern California may never be the same.
My name is Vienna Saccomanno. I'm an ocean scientist with the Nature Conservancy, California, and these are our notes from the field.
A combination of factors, from a climate-driven ocean heatwave to a deadly epidemic under the waves, nearly wiped out the sunflower sea star, an important predator of kelp-eating purple urchin. With no sea stars to eat the urchin, their population exploded and they devoured their main food source, kelp. By 2019, 96% of California's North Coast kelp forests along 200 miles of coastline were destroyed. I am part of an amazing team working to detect and protect the kelp we have left and restore these forests and the ecosystems they support. To do that, we're constantly looking for the smartest, fastest, and most efficient ways to help. And today, that means drones. I wake up while it's still dark. It's a fall day during the lowest tide of the month when the water is at its lowest and the kelp fronds rest on the surface of the ocean. It's our mission to map and monitor as much of California's remaining North Coast kelp as possible, so we're making sure all the conditions are in our favor. California's kelp productivity historically rivals that of the Amazon rainforest and has immense impact on jobs and revenue for our state. But we can't save the remaining kelp if we don't know where it is. The team and I arrived last night in Mendocino, a remote area of the Northern California coast. We charged our drone equipment, double-checked our flight plans and permits, monitored the weather conditions, especially the wind, and downloaded our maps because there's almost no cell service out here. Funding for restoration is limited, so we need to be as strategic as possible to make sure every dollar and every minute spent resetting this ecosystem is making the biggest impact possible. That's why I'm out here mapping kelp. But most importantly, I'm mapping kelp strongholds. A stronghold is a place where kelp thrived during the good times and survived even during the hard times. Thanks to our drone team and our amazing partners, we can see every possible patch in the priority sites we fly, down to the pixel, and that's not an exaggeration. When we look for kelp using Landsat satellite imagery, each pixel represents 30 meters. In our drone footage, each pixel represents 3 centimeters. Today, my drone flies approximately 400 feet above the water and takes about 2,000 pictures in a day of surveying. It's a fully autonomous flight, following a flight plan I created in advance to be sure it covers the areas most likely to have kelp. The result is some pretty epic footage. While the drone is flying above, I'm looking at my controller, which shows me every image as we're capturing it. If anything throws us off plan, I'm ready to jump in and take over. After a successful flight, I land my drone and head home with thousands of images. Then I run my images through a deep learning algorithm created with partners at the Hakai Institute that identifies pixel by pixel where the kelp is. Each new mapping mission adds more data to our understanding of this important ecosystem and literally allows us to see how the abundance of kelp is changing over time and space, and just how strong our remaining kelp strongholds are.
Hi, my name's Luba Reshitnyk. I'm a remote sensing scientist with the Hakai Institute in British Columbia.
Luba has been pushing the frontier of kelp mapping for nearly a decade. With the help of computer scientists, she is now taking her science to the next level by creating an open access artificial intelligence tool that will help kelp mappers around the world speed up their work using drone imagery. It's called the Kelp-O-Matic, and it's what I just used to analyze my images. The Kelp-O-Matic can take our drone images and detect which pixels are kelp and which are not. From there, it makes a detailed map of where every pixel of kelp is located in our sites. TNC scientists can then use this map for strategic monitoring and restoration. In the past, mapping a single area would take days to weeks. With the Kelp-O-Matic, we're able to create analysis-ready data in just a few short hours. One thing I love about this method of mapping is how accessible it is. High-quality drones are now easily available, and our partners have made the AI tool that we use to classify kelp open source, lowering barriers to entry so that kelp restoration practitioners everywhere have the tools they need to do this work. Once the Kelp-O-Matic has completed our maps, I bring our findings to the California Department of Fish and Wildlife, which is in charge of managing our state's kelp forests. And this year is particularly exciting because we get to deliver our maps the same week we conducted our surveys, all thanks to the Kelp-O-Matic. It feels really good to complete high-quality science with our partners who love kelp, an amazing female-led team, and to have the technology that allows us to do this work at a pace that can really make a difference. Together, we are recovering underwater forests one patch at a time.